Hello, and welcome back to the course on Physics for Engineers. We are still on Chapter 11 of this course. So before we proceed with this lesson, let us first review some concepts. So in the previous lesson, we have discussed about Coulomb's law for electric field and electric force. So in this lesson, we will try to formulate the same expression, the same Coulomb's law expression, but now it is for a quantity called electric potential. So before we discuss about electric potential, it's actually related to a quantity called electric potential energy. So basically the potential to do electrical work. It's analogous to gravitational potential energy and elastic potential energy. So potential to do work. In this case, electrical work. So the electric potential energy U is given by this expression. So this is the Coulomb's law for electric potential energy. And this is the energy used by the system of two charges, Q1 and Q2, for their interaction. Take note, you cannot exert a force or you cannot do work such as exerting a force, if you don't have energy. So the energy used by the system in repulsion or attraction is given by this expression. So if the potential energy is positive, it is actually a repulsion, and if the potential energy is negative, it is actually attraction. So if you will recall, if you have positive and negative charge, of course Q1 is positive, Q2 is negative, you will have negative U, and that's actually attraction. And then if you have both same charges, you will have repulsion. So the SI unit of electric potential energy is, of course, it is energy. The standard unit for energy is joules. So electric potential is just describing electric potential energy on a per unit charge basis. So the electric potential has a symbol V. It's U over Q. The potential energy per unit charge. So it's Coulomb's law form is KQ over R. So the standard unit for electric potential is volt, the symbol V. So please don't confuse the name of the symbol for the potential and the unit for the potential. It's actually the same letter, capital V. So 1 volt is 1 joules per coulomb. So this is joules, this is coulomb. So joules per coulomb is 1 volt. So in this chapter, or in this lesson, we'll actually just focus on voltage, which is just the potential difference between 2 points. VA, so the potential, VAB is the potential difference or the voltage, because you will use this later in your electricity circuit topics. It's just the potential at point A versus the potential at point B. And this is actually equal to the work done by the system or on the system when the particle or when the charge moves from A to B over Q. So you might have heard voltage before when you are talking about a battery. So a battery, for example, this is a battery which has a potential difference or a voltage of 1.5 volts, meaning the potential at point A, in this case the positive terminal, minus the potential at point B, the negative terminal, is equal to 1.5 volts. So it could be the potential here is 0.75 and the potential is negative 0.75, so that you will get 0.75 minus negative 0.75 is 1.5. Or actually it's not exactly like that, but in a similar situation. Okay, let's proceed directly to an example. So similar with electric field and electric force, electric potential energy and electric potential obey the principle of superposition. But now, it's not exactly a superposition of vectors, but just a regular addition. So if you want to find, you have we have this distribution. We have Q1 at x is equal to -3 meters, Q2 at y is equal to -4 meters, and we are asked to find the potential at the origin at x is equal to 0, and that is at point A. So to find the potential at point A, we need to find the potential at point A due to Q1, V1A, potential at point A due to Q2, V2A, and using the Coulomb's law formula, V1A is just K Q1 over R1A, where R1A is the distance from Q1 to point A. And then for potential due to Q2 at point A, potential of this charge at this point is just KQ2 over R2A. So you factor out K and you have that expression. So you substitute all of the values. Q1 is 1 nano coulomb, so 10 to the -9. R1A, distance from Q1 to point A, that's obviously 3 meters. R2A, distance from Q2 to A, that's obviously 4 meters. And you will get a value of, so substituting all of the values, you will get a value of 0.75 volts. So this is the potential at point A due to Q1 and Q2. So let's now try to find the potential at point B. So in a similar manner, we still find the potential at point B due to Q1 and due to Q2. So we have a similar solution. Actually, the solution is actually the same. The only difference is the distances. So the distance now from Q1 to point B, so since point B is at x is equal to 3 meters, so this is 3 meters, that's 3 meters, so you have 6 meters. And the distance between Q2 and point B is the hypotenuse of this triangle. So this is 3 meters, this is 4 meters, so therefore the hypotenuse is a 5 meters. So this is a special triangle called a 3, 4, 5 triangle. So it's 5 meters. So that is R2B. And you will get a value of -0.3 volts. So in the previous problem, you get a positive quantity because the potential due to this charge is much stronger because it is much closer to point A. But in point B, Q2 is now much closer to point B as compared to Q1. Q1 is 6 meters away from B. Q2 is now 5 meters from B. So this has the most contribution. That is why it is negative 0.3 volts. For the last problem, we're now trying to find the potential difference. So if you are asked to find the potential difference between point A and point B, then you just subtract the potential at point A and minus the potential at point B. And since we already have solved the potential at point A and point B due to the two charges, then we can have the voltage between point A and point B. And we get a value of 1.05 volts. Okay. So that is the end of this lesson. So we will try to use the concept of potential difference of voltage in the succeeding chapters of this course, especially when you go to circuits. So the next lesson for this course will be the last lesson for the chapter on electrostatics, and it will all be about capacitors. So capacitor, this will be the first basic element of the circuit that we will be discussing. And there are actually 3 basic elements. You have capacitor, a resistor, and an inductor. So I will see you again in the last lesson for this chapter.